Need to lock down your FastMCP server so only authorized users can execute tools and access resources. You'll see exactly how to define granular permissions using Permitio's authorization system, mapping MCP server methods to protected resources and actions. We'll configure an admin role with explicit access to tools like greet and add, while restricting unauthorized operations, all through declarative policy definitions.
Hash resources. Resource, Permitio resource. MCP server. Name, MCP server. Key, MCP server. Actions equals. Greet equals name equals greet. Add equals name equals add. Resource, Permitio resource. MCP server tools. Name, MCP server tools. Key equals MCP server tools. Actions equals. List equals name equals list. Hash roles. Resource, Permitio role. Admin. Key, admin. Name, admin. Permissions equals. MCP server greet. MCP server add. MCP server tools list.
This demonstrates resource-based access control integrated with a middleware pattern for authorization. The configuration defines protected resources like MCP server and MCP server tools, and maps specific actions such as greet, add, or list to those resources, creating a clear boundary between what can be accessed and how. The distinctive aspect here is the separation of policy definition from enforcement, allowing authorization rules to be managed independently of application logic. The middleware intercepts requests and automatically translates them into authorization checks against predefined policies. By mapping MCP methods to resource action pairs, e.g., tools list, MCP server tools, list, it enforces permissions declaratively without requiring manual checks in your code. This design leverages attribute-based access control, ABAC, for dynamic conditions, such as tool arguments, while keeping the core server logic unaware of authorization complexity. This approach solves the problem of embedding permissions directly in business logic, which leads to tight coupling and maintenance headaches. It's particularly valuable for multi-tenant or role-based systems where access rules change frequently. The trade-off is added dependency on the policy service, but the benefit, centralized, auditable, and scalable authorization, far outweighs it for most production environments. Let's break it down.
Resource, Permitio resource. MCP server. Name, MCP server.
This defines a Permitio resource named MCP server, establishing it as a protected entity in the access control system. Resources represent the objects users can interact with, and this declaration creates the foundation for permission checks against this specific server component.
Actions equals. Greet equals name equals greet.
This defines an action named greet for the resource, mapping it to the greet permission key. Actions represent discrete operations users can perform, and this pattern establishes the granular permission model for access control. Each action becomes a checkable permission in role assignments.
Resource, Permitio resource. MCP server tools. Name, MCP server tools. Key equals MCP server tools.
This defines a Permitio resource named MCP server tools, establishing it as a protected entity in the authorization system. The key parameter creates a machine-readable identifier for policy references, while name provides human-readable context. This follows the standard resource definition pattern, where resources represent API endpoints, microservices, or data entities that require permission control.
Actions equals. List equals name equals list.
defines an action called list for the MCP server tools resource. This establishes a granular permission that can be assigned to roles, enabling fine-grained access control over specific operations. The pattern mirrors how REST APIs scope permissions to individual endpoints.
Resource Permittio role. Admin. T. Admin.
This defines a role identifier using the key admin. The key serves as the unique, machine-readable reference for this role in Permittio's policy engine, enabling consistent role assignment across the system. Resource Action Pattern. The Terraform configuration demonstrates FastMCP's fundamental authorization model, where resources like MCP server and MCP server tools define discrete actions, greet, add, list, that become the atomic units of permission. Permissions must use the exact resource, action, syntax, and role definitions, as the system performs literal string matching against these keys. This declarative approach lets you model complex access control as simple resource action pairs.
The permission that names everything controls nothing, while the permission that names nothing controls everything.